This is we are.
My life is a party, my home is the club. I party like a rock star, dance until I drop my love.
Today we're going to start with our first physics chapter, which is measurements and uncertainties. This is one of the most basic chapters you're going to ever do in IB, for at least physics. First we start off with the SI units. SI units are very important as they are used to compose most of the other units that you'll be dealing with later in your IB course. So the most basic units, which compose of most units you'll be using later on in the year, are the SI units. These SI units, most of these are based on mathematical equations. However, except for mass, which is, funnily enough, it's observed by a mass, a bowl of steel, in Paris under lockdown. That's what kilogram is. So first of all is meters, which is a pretty simple unit. After that we have kilograms. Kilograms is the only SI unit which is measured in kilos. Then we have temperature, which is Kelvin. Kelvin is Celsius plus 273, which is very simple. Then second, which is considered the most basic, time unit. Then the amount of substance, mole. Mole is something you will deal with in chemistry as well. It is, let me do it now. Yeah, it's the number of atoms in 12 grams of carbon 12. Then we have ampere, which is the unit for electric current. And finally, the last one, which we don't need for this IB study, is candela, which is how luminous an object is, or how sunny a sun is. After this, we have the metric multipliers, which is basically speaking anything like 10 to the power of any number. This allows us to shorten most numbers to what seem to be manageable. Like, for example, the mass of the sun is 1.989 times 10 to the power of 30, which if we put zeros, then it would take a lot of time. So these metric multipliers are used to shorten the number as well as make it easier for data manipulation. Now we'll be going on to the uncertainties and errors. Okay, first of all, there are two different types of errors. There are systematic and random errors. Systematic errors occur when there is a consistent problem across all different tries in an experiment, while random error occurs only in a few. For example, if I threw a ball,
keep eye contact with the camera,
with more force when compared to the rest, that would be a random error. While if there was a zero error, which means that the mass on the weighing scale does not start off as 0 and instead starts off at 0.01 or 0.02. So then we can discuss accuracy and precision, now that we know the two different types of error. A system is accurate in case the systematic error is small, while a system is precise in case the random error is small. So in case you shoot darts in a particular area, although it is not at bullseye, it would be considered precise. But in case you shoot darts at bullseye a lot, then it's considered accurate. Okay, now we will start discussing averages of data. This is very important for your IA and any experiment you'll be doing, like the 12 different experiments, I believe, that you'll be conducting over the course of the year. This is the general method of calculating the mean, which is addition of all different values and then division by the number of values there are. After this, there's two different types of way of calculating error. This is the first one, which is considered more refined when compared to the other one, which is simply the subtraction of the minimum from the maximum and then divided by 2. This, however, gives us a more a smaller error, thus allowing us to eliminate anomalies with better efficiency. So in this case, we first we take each value of x and then subtract it by the mean and square the answer, and then we add them and divide them by n. That's standard deviation. Vectors and scalars. So scalar is a magnitude with no direction, and a vector is a magnitude and direction. So in case we were the speed would be a scalar quantity, while its vector counterpart is velocity, which has a direction it's acting in. There's addition in case the vectors are acting in the same direction, then they complement each other, thus resulting in, for example, in case here and here, they're complementing each other because they're not restricting the other vector's movement. Thus, this would it would be A plus B, which is A standing for green and B standing for red. Great. However, if we consider these two here, we can state that they're moving in opposite directions. Thus, they would restrict each other's movement. So in case we were to do this, then we would have to subtract R from B from R. So that's basically the addition and subtraction of vectors. It's very simple comparatively. Now we move on to the components of a vector, which is in case it's moving at an angle, then there's a vertical and a horizontal force acting on it. Here this arrow here is moving in an angle, so it has a horizontal and a vertical vector. The horizontal is always the vector times cos theta, which theta in this case would be the angle, while the vertical is always 8 times sine theta, which is the vertical angle of, vertical component of the vector. Yeah, that's about it. It's very strong.
Hi, thanks for watching this video from our video revision series. To watch other videos from this subject, click the playlist on the right, and to see the bloopers of this video, click the video to the left. Make sure to leave a comment with any topic suggestions you may have, and subscribe to see when it comes out.